Okay, so domain name system, DNS. This is a system involved in getting the IP address from our domain name. So when you type in on the browser and you visit, say, google.com, to actually be able to send data in packets across the internet, you can see my video on the TCP/IP stack, we need to actually send using a source and destination IP address, not a domain name. So this is where DNS helps us, because we can give our domain name to our DNS and it will give us the IP address. So let's take a look at how DNS works. So you're on your device in your home network and you type in to the internet, your browser, you type in google.com, okay? So maybe in Safari, you typed in google.com. Now, to visit google.com, you need the actual IP address of google.com. And the way you're going to get that is your phone is going to send to the router, hey, I need the I need the IP address of google.com. And then the router will know what to do. The router is going to send to your internet service provider. And the internet service provider is going to contact the DNS server. And this is going to be responsible for running the algorithm that actually gets your IP address. So what's going to happen here? So if we expand what's going on inside here, so your DNS server here, which is this, and this, is going to send the request and ask the root server first. It's going to start at the top of our tree and traverse downwards. And this is the recursive manner. So it's going to ask the root server, hey, do you have the IP address for google.com? And as you can see on the tree, the root server does not. So the root server will respond and say, I do not. But what the root server can see is its child nodes, and it can see, okay, since you've asked for google.com, why don't you check out the TLD server? And so our DNS server has now done that. It's now going to contact the TLD server and say, hey, do you have my address for google.com? And the TLD server, as you can see here, does not have the address for google.com. However, what it can do is it can see its children, which are authoritative name servers, and it can say, why don't you check out the authoritative name server for Google? So .com is going to respond by saying, no, but check out the authoritative server for Google. And then finally, our DNS server is going to then contact the authoritative service for Google, which is www.google.com. And then finally, this server, step 3, will respond to the DNS server with our IP address, which is, as we can see here, 190.0.0.0. And so now our DNS server has 190.0.0. This is going to get forwarded all the way back to our device. So our device will finish with the IP address of the domain name google.com. And this is the hierarchical nature of our DNS, because we have to traverse in a hierarchy our tree, which helps us because it speeds up the process of getting our IP address. If we had to just look up the IP by searching through every possible one, that's going to take a long time. But by having hierarchies that operate on multiple servers, we can say, okay, root, now where do I go? Okay, you want to google.com, so just check for the .com nodes. So we've eliminated the need to check the other nodes. Now, as we saw here, once we search google.com into our browser, say we searched google.com in Safari, we had to go and do this whole process. We had to leave our home network to go to the ISP's network and then to their DNS server in order to do this. However, we do not always have to do that if we do caching. So if we cache the record, and the record is just a mapping. So if we search google.com, and then the first time we did this entire process, this entire DNS lookup, we just then get the IP address back, but then we store the IP address. And we can give that a time to live. So this mapping, which is name, IP, we can give that a time to live and say, okay, I want this mapping to last 1 day. So this could be stored on your browser. So say if you were using Safari and the first time ever you typed in google.com, you go through this whole process to go to the ISP and then do this whole traversal. Then once you've done that, Safari will store our nice mapping for us. So the next time your device says, okay, google.com, we don't have to do this again. You can just ask Safari to say, hey, remember the record that you saved last time? Can you give me the IP address for google.com? And Safari will handle it. There are other levels of caching. So your browser doesn't always have to handle the caching. This could be stored by your operating system in your computer. So your browser, like Safari, will say, I don't have a mapping. I don't have this cache record, but I will check the computer, and the operating system will handle that for you. So if the cache is stored in your computer, it's going to be stored in the physical hardware, in the storage. So this is what will have your name IP mapping. So Google and the physical IP address, which is this. And what your application will do, so we're at the application level now, is Safari will say, okay, you typed in google.com. I don't have the mapping, but I'll ask the operating system. So Safari will ask the OS, and the OS will say, okay, let me check the storage for you. And it will say, right, we do have this mapping. I'm going to send the IP address to you. So caching is just all about when we initially get our IP address back, we save the mapping so we do not have to rerun our entire search.